Welcome, guys, to another Recro's webinar. We are having with us today Nimit Khandelwal, and this session is a continuation of our previous session on node.js design pattern. That was a beginner level session, and this one is intermediate level session that's going to be deep dive. This is Sana, and I'll be hosting this session today. I'm working as a community initiative lead at Recro, which is a developer-centric organization wherein we are trying to connect developers' aspiration to the right opportunity by working with the high-growth startups like Swiggy, Udan, Dunzo, CureFit, and many other similar line of startups. And here in this session, I think Nimit would be the right person to tell you more about it. I can tell you about Nimit. So Nimit is working with paper right now as a senior software engineer, and mainly like he's having around 4+ years of industry experience working on the JavaScript side majorly. And I think about the topic, he would be the right person to tell you more in detail. And yeah, let me tell you about the platform. So we are on AirMeet right now. So on the right hand side, you can see 3 to 4 options. One is session. So in today's session, it's going to be like this is a welcome session, which will be followed by presentation and demo by Nimit, and he will be like having a lot of, I would say, live coding demos here. And post which, like, you'll be having a 5 minutes of break in between, just so that you can just relax and can grab your coffee, tea, or anything. And after which we'll just resume the session. And for the Q&A, we will be having in the end of the session. Like once we are done with the session, then we'll be having the Q&A. Down that you can see attendees, where you can see what, like, who else are there in the session attending with you. And after that you can see chat section, where like you're chatting right now, the same one, and you can talk about anything about the topic also. And then you're seeing this question section. So I would just request you to please keep your questions only in the question section, so that we can just like keep a track on it. Here you can upvote also, depending on like if like some question and you too want to ask the same question, you can keep it there. You can anyway in the whole session keep on asking the questions there and keep on upvoting it, because we will be sorting it by upvotes. So whichever question is most upvoted one, we will be taking that first. Okay. So that's it about the upvote. Apart from that, you can always raise your hand if you want to come here and ask your question. Like if you're having some big question in your mind, obviously you can just raise your hand and I can allow you here, and you can ask directly to Nimit whatever doubts you have. Apart from that, the down the line you can see a raise hand option. There you can click a hand kind of something you can see there, and you can just click on there, and it'll just raise your hand and I can allow you there. Apart from that, you can see reaction one also, like on which you can just click there, whatever you are liking something, like this is gonna be. And yeah, that's it about the Airme platform. I think it's very simple and quick. And I'll just hand it over to Nimit. I hope I did not forget anything to tell you. And yeah, on to you, Nimit. Thank you so much to be here.
So hey everyone, I hope you are all good and well in this coronavirus session, coronavirus time. And Sana has already introduced, told a bit about me. So now, without further delaying the session, I would like to start. And before that, I have attended my previous session, and what was your feedback about it?
6% people they have watched the video recording, and 94% did not. Anyway, I'll share the link in between also, in between the session, so that you guys can just go and watch. We'll start with this session minute.
Yeah, this is a bit about me. You can always go to my LinkedIn profile and Instagram page. Uh, and most of you already know about me now. So I'll just skip this part and let's recap what we have learned previously. So last time we talked about how the module system works. We talked about different small patterns like observer pattern, um, revealing constructor patterns. We talked about iterator patterns, right? Then we talked about promises, async await. How do they work in practical way in large applications? We had some examples of crawling web, a small crawler which we implemented, and that by that way we were trying to do some like unlimited crawling, and then we kind of implemented a pattern where we could limit the concurrency using event emitters. So I guess now you are all comfortable with using using those in your day-to-day programming, and this helps us a lot whenever we are doing any kind of async operations, right? And it basically helps us to do use the node.js paradigms, use the node.js technology, um, very in a very beautiful way, like rather than just implementing something which is being done earlier, right? We can we can actually use node.js. It's all the patterns which are given in a very beautiful way. So now talking about this design patterns, right? We so after learning these principles, right, still there is a question that uh, how do we make the programming better? Like let's say if we are having a versatile team, so how do we design this software by which it is easily extensible, it can be easily managed, like so that anybody who is coming to the project newly, right, uh, can have a better understanding, like what this project is doing and how it is doing what, right? So it will be very easy to onboard him, right? So keeping that in mind, let's start this session. And so in this session we will basically talk about three types of patterns. Those are creational design patterns, structural design patterns, and behavioral design patterns. So if I talk about like these are the three patterns which are mentioned in Gangs of Four Design Patterns book, right? So this is a very popular book. You might have heard of it. Those who haven't heard of it, I would urge you to please read this book. This is a really good book about design patterns, how they have evolved in software industry, and how those are beneficial. So uh, like you can just Google the link and you would find it. So now coming to this these like uses of design patterns in node.js, right? So apart from these three patterns, node.js has provided since node.js is based on javascript, right? Node.js doesn't have any like it's since javascript we know that it doesn't have any real classes or any abstract interface, right? And design patterns basically work really well with object oriented designs. Like in Java, we can talk about Java, but since JavaScript is like object oriented but prototyping based, and it has dynamic typing, so it treats functions as first class citizens, and it also allows us to do functional programming. So these are the characteristics which make JavaScript a really different language, and it gives us a power, like really good power, uh, to control, like to change the code to very easily and do a lot of operations without making much changes. But it comes with a lot of like you know uh, different techniques. Like we need to know about different techniques, how we can achieve the same, like how we can achieve the results. So if I talk about in JavaScript, we can achieve the same results in many different ways. Like for example, map function, right? We can have it with respect of iterators. We can use reduce APIs, we can use map APIs, we can do we can use iterators, generators, everything, and achieve the same results with different APIs. So let's see how these things works and how it adheres the JavaScript ecosystem, how these patterns work in there. So let's go. Let's start with the creational design patterns. So in creational design patterns, we have, like, I will be talking about these five patterns mostly. One being the factory pattern, then revealing constructor pattern, builder builder pattern, then singleton pattern, and a dependency injection pattern. So, like, if we as the name suggests, right, these patterns basically address problems which are related to the creation of the objects. Whenever we are creating any uh, bigger project, right, how do we structure our responses, or data models, like how do we store the data, and how do we construct the object which is being passed through different classes. So that's where this creational design pattern helps us a lot. And factory pattern, if we talk about factory pattern, right, it allows us to encapsulate the creation of an object within the function itself. You can consider this as a closure, and it also address so now if we talk about revealing constructor patterns, revealing constructor pattern is basically uh, it exposes private property at the time of creation only. So if you and you can't change them later. So if you talk about strings, right, we can create immutable objects in for example, in Java, strings are immutable, they cannot be changed. So if you want to do any kind of modification, you have to create a new copy of it. You can't change the existing object itself. So this kind of constructor, revealing constructor, basically address those kind of issue. Then builder pattern is how do we simplify the creation of complex objects? How do we build them sequentially one by one? And then singleton pattern, most of you already know about, like how it works. As the name suggests, like it can have only one copy. So how we can use it in our project, and what kind of problems it gives, what kind of benefits are there, we will talk about that. Then dependency injection pattern is basically composition of the classes. So if we now, like, most of you have been using these kind of patterns a lot, even if you're not aware of it. So we are just gonna define the names here to those patterns, and we will give you an idea, like, okay, what you are doing right now. So let's go ahead with the factory pattern. So factory pattern, no, this is the most common design pattern in Node.js. Like it is very versatile, and it just has one purpose. Like it's not just have one purpose; it has more than one purpose. So like the main advantage of is it gives us ability to decouple the creation of object from one particular implementation. Okay, so and like object create for example, to create any object, the whole class, like which class we need to provide, that can be determined at the runtime only. So let's do one thing, let's understand it better, how what I'm trying to say. And let's consider a scenario. Okay, so let's consider a logistic company. And so um, this logistic company, let's say we have started one logistic company from scratch. Okay, and we are just currently going with road transports. Okay, now at the time, like we got a lot of traction from users, and we started expanding a lot. So now instead of road transport, we want to actually go with again sea logistics also. So how do we how do we incorporate that in our project? Like one way is to do inherit of the classes. Like let's say we had a logic we had truck class, we had or then we can have our ships class, and that can be like inherited from some interface, common interface. But that would require a lot of change, right? Let's say we have this app now. Now we had this road transport class, and um, everywhere we had like tightly coupled object. So how do we change the system so that it can go ahead, it can just integrate the sea logistics seamlessly, right? So what we can do is we can create we can use the factory pattern to decouple it, and uh, it basically it will allow us to choose choose the logistic type at the timer or at the runtime, and based on the preference we can choose like whether we want to go ahead with road logistics, I mean transport, road transport, or sea transport. Okay, so this factory pattern is gonna help us in that way. Okay, so now let's consider one more example how we can do it. So let's say we had a simple factory. So a simple factory example can be like this. So we are creating an image and we are returning it with a new constructor, new image, and this function is basically a simple factory. Now we can just call it via the constant image equals to create image. Okay, so this is a simple factory. So now there is a question like why do we need to again create a one more function? Why can't we just use new image, right? But what if what so this is fine for small thing, but what if we want to have different type of images, right? Let's say it can be jpeg, it can be gif, it can be png, it can be any other type of image, right? So again, this will require a lot of change. But if we have a factory like this, we can have dynamic types like based on some conditions, we can just do it like this. So it will have like based on, like if the name matches from JPEG, then it will return us JPEG image, otherwise GIF image, otherwise PNG, and then it can support us for error handling also, right? So now if you see that everything looks similar, the only change which we did was in create image, and our application didn't had to go in much changes like how we are calling the objects. Everything like if we consider the client which is calling the create image, right? It didn't had to change any single line of code. We all we did is changing in the factory itself, right? So this gave us a lot of flexibility in terms of like detailing the creation of those objects. Okay, so this is how we can do. Now let's talk about one more advantage which it has. Okay, that is called encapsulation. Okay, so encapsulation is basically like encapsulation like controlling the access of the internal details of the object. Okay, so like from external person. Okay, so that they can't manipulate them directly. So what we can do is, let's say we have a person class, okay, and we have a factory method called create person. So this function can take care of creating the person object, and it can take care of, or like if you see the second last line, right? It is changing the name of the person. It is setting up a name, but here like it creates it into private properties. So whenever we are trying to change anything, right, we don't have any person context. All we have is a function, a set name, and get name that is available to us. We don't have any control over the private properties of it. We can always access them by like these closer functions, okay, but we can't access them directly. Like we can't do create person dot name, something like that. So this provides us encapsulation, like hiding the implementation details, how it is implemented. Okay, but this is not just the one. This is not just not one way to do it. we can do it in other ways also. Like here we are using closures, right? But in JavaScript, like in Node.js, we can use symbol that came into ES6, I guess, and then we can use weak maps also. So that similar thing can be achieved in different ways. Um, so that is the power of Node.js. Like we can achieve the same results with different things. Right. Let's now do one thing. Let's try more concrete example, that is a profiler. Okay. So what we will do is we will create a profiler that is for use for logging purpose. Okay, and we will see how this factory method works, like how this factory patterns work seamlessly there, and what are the advantage we have. Okay, so let's move ahead to the code. I guess, like, I hope you are able to see. uh, so this, okay, and I have like we have shared the GitHub also, GitHub link as well, so you guys can go through the code as well and see what we are explaining. So let's say we have a simple profiler class.
If you can just increase the font a bit, like I'm not able to see that. Let us know if you guys are able to see that.
Okay,
I'm anyway sharing the GitHub link.
is this
I think it's better. Can you guys let us know like if it's better for you or not? Not able to see. Still the methods. Is it okay now, Prashant? Better. Okay.
okay?
You just increase one bit more. That's it. That should be better. Yeah, better. I'm sharing the
Okay,
GitHub link as well. So in case if you are still not able to see, you can refer the code there as well. Okay.
okay. So now let's consider a profiler class. Okay, we have a constructor that is getting a label inside the constructor, and we basically have a function that calls start time. Then we have end function that calls end time. Okay, but what the problem is that like let's say now we have before going to the rest of the functionality, let's say we have um, what we want to do is we want to do the profiling of this application, and whenever we call any function we can just do profile.start and do profile.end, and it can log the time which is being taken. Okay, but the problem is that it will bombard like let's say if we are moving into production, right? Then this profiling would be a good idea, because whenever we are running any application it will bombard the logs for us, right? And in production we don't want to take that kind of a risk, right? So having it in dev environment makes sense, but having it in production won't make much sense, of doing the profiling again and again for everything. And this but now since we have embedded everything into the code, how do we get rid of it? Like, we don't want to do it in production, but we want to do it in dev environment, and it won't be a good idea to do making a code change for environment specific. Correct. So what we can do, so if we see that in this get all factor function, we are calling this profile.start, and then we are running a function and we are calling profile.add. So let's go into the profiler. Profiler is basically we are instantiating it with the create profiler, that is a factory which we made. Okay, now what we can do is we can have this factory based on the environment itself. So let's say if it is a production, then it will return an empty object. So start won't have anything and end won't have anything. So even if the function is called, nothing will be printed. Correct. And if it is dev environment, then it will return the current profiler to us. Okay, that is new profiler with the label. So this is how we can This is how we can make a difference, like we use the factory pattern effectively and without doing any kind of change on the client side, that is index.js for us. Okay, without making much change, any change here, we can just change in the factory and everything will remain same under the hood. So once you have implemented anything, you don't have to change it. So that's a bit about factory pattern. Now let's talk about builder patterns. Okay, so builder pattern is basically, again, it basically simplifies the creation of complex objects by uh, providing what do we say, a fluent interface, which will basically allow us to build the product. I mean, build the object step by step. Okay, and it improves the like it basically helps us to improve the readability. Okay, readability and developer experience. Let's say we are creating complex object. Okay, that time it will help us a lot. So um, now let's consider a scenario. Okay, we let's say that we are trying to build a house. Okay, now house can be built, like a house can have different types. Like house can be built with garage, or maybe fancy statues, or it can have swimming pool, or it can have garden, right? So every house isn't like same, but some addition, it comes with some additional features, right? If we consider it in object paradigm. So how we can create this kind of scenario. One way is like we can just have a house interface, and then whenever we are trying to create a new kind of house, we can just inherit the functionality and make the changes accordingly, right? But this kind of practice won't be preferred, right? Because let's say we are coming up with some new designs of house, then again for every new design we will need to do a code change, having an instantiation of this, like we will need to inherit one more object, and then we'll need to make the change there. So this will create a lot of problem, like unnecessary classes we need to create and unnecessary things we will need to create. So how we can avoid this kind of scenario? So wha- now one way in to achieve it in JavaScript, like we can just have a weak method, that is like house constructor we can have, and we can pass it with number of arguments, like has doors, has room, has garage, has swimming pool, and whenever one property is needed, we can just pass null of like true false, or maybe if it is not needed we can pass null value or something. But again this will have these number of arguments can increase a lot, right? And also it will confuse whenever we are trying to read the code. We will need to again go back and check the references. Okay, this is what this option means, right? So this is not the right way to do it. So what we can do is we can create a builder around it. So we can divide this house into patterns. Okay, and each we can divide this house in different steps. So one will be one function will be responsible to build the walls, one will be responsible for doors, windows, roofs, garage, something like that. And then we can we can get a combined result. Okay, so this will basically solve the problem for us. Now we can, whenever we are doing anything, we can just pass how many walls we need, how many doors we need, how many windows we need, whether we need a garage or not, or something like that. Okay, so let's see how it looks. um, let's say we built now let's take a boat, example of a boat. Okay, a boat can have if in a simple way, if you look at the left side class, there is a class called boat, and we have inside the constructor we are passing number of arguments like has motor, hull color, sales count, and everything. So one way to achieve it, that why not we like one way to solve it in JavaScript is that why not uh, we pass them in as a object itself. Instead of passing number of arguments, we just pass one object that is having everything, right? But again, if you see this, right, again you will need to provide all the arguments which are needed or which are not needed. And every time, whenever, let's say if you are adding a new property, right, and that is a required property, then how would you change it? This, there is no way to change it. And again, you it won't be improving the readability. Like, you have to maintain the variables here, then again you have to check it there. So what we can do is we can have it something like this. So we can have a builder class, um, and with builder class will basically have some functions like with motors that will take three parameters: how many counts we want to have, what brand we want to have, what model we want to have, and then it will return the same reference of the board itself. And then with sales, so it will divide the properties based on the type. Okay, so 9 properties will be divided into 4 types. And then instead of return, and then we can have a final build function which will create everything for us. Okay, so under the hood, let's say we will be having the same structure. Like in board class, we will be passing the whole object as the same. Okay, but if we look at the client side, right, in client side we don't have to worry about these many like we don't have to pass these many these many arguments in one object, these many properties in one object. We can just do uh, create my boat with builder class with this with 2 motors. The company is this, the brand is this, and with sales, with one sale, it should be fabric and white. With cabin and hull color should be blue, and then at last weld it. So it will return it will return uh, the boat object to us, and we don't have to worry about the implementation. Now whenever we want to change anything, we can just have one more um, like dot do something, right? Some We can use build a pattern like this. So now let's talk about another example which you have been using, and which is based on builder pattern only. So you might have used super agent or request request classes, right? Request APIs. So we do request.post, .send, .set headers, and then we have a denify, right? So this is based on the build pattern itself, where we set some of the properties, and ultimately, okay. So this is how we can achieve the builder pattern. Now let's see if we have any example of it. Okay, right now, yeah, I think this is the, yeah, this should be the example. So like I was talking about the super agent. Like we are basically using this request library and other libraries a lot, which are based on the builder pattern itself. So this is the example for like a real life example of builder pattern. Now let's talk about a different pattern, that is revealing constructor pattern. So as I told earlier, that revealing constructor pattern is that like we can hide some private property, like we can do the change in the object at the time of creation only, and it will create some immutable objects for us that we can't change later. And we can achieve this, helps us a lot maintaining the object lifecycle. And like if you see React, right, in React we do state changes, we do a lot of changes. And when we do store management, right, store management also gets done by immutability. So though, like there we use these kind of patterns a lot. So now this kind of pattern you won't find anywhere in Gangs of Four book. So this is basically uh, it works well with Node.js. So it came up with Node.js itself. So like since it originated from the JavaScript only, right? So what we can do is let's see how we can uh, create this kind of pattern in our day-to-day programming. Okay, so this kind of pattern, as I told, right, it addresses few scenarios. Like object creation can be modified, like object which we are creating can be modified only at the creation of time, and their behaviors also can be defined only at the creation time. We can't change them later on. And it can also be initialized only once at the creation time itself. After that, you can't do anything. So let's see how we can look at how we can do it. So it comes up with three type of things. One is the target, which we have. Okay, uh, it has three kind of elements. One is the constructor. So it will basically take a input function as an input. Then we have this executor function, which will be basically executed at the runtime. Okay, I mean, you can say create it for runtime. I mean the creation time itself. Okay, so it will be executed at the creation of the creation time, and it will basically receive a subset of object internals. Okay, the properties which we want to have in the members. Okay, I mean the properties which we want to assign to the variables. Okay, which cannot be changed later on. So let's see how it works so that you can get a better understanding of it. um, let's look at the code. Like let's do one thing. Let's try to create a immutable buffer. Okay, which will basically uh, allow us, like, which will provide functionality so that we don't need to create copies before um, we don't end up creating uh, like create mute doing any kind of mutations if we don't want to. And it will so let's see how it works. So immutable object is basically a property of an object which is its data, and its state becomes unmodifiable once it is created. Okay, so let's go through an example how we can do it. So this immutable buffer, right, immutable buffer is basically uh, it will help us to keep this kind of pattern in immutable buffer will help us um, doing the state management in a proper way. So what we can do is, let's say we have a immutable buffer class. Okay, and that will accept two type of things. One is size, then the executor function. An executor function will have some modifiers passed into it. Okay, so as we talked in the slide, right, that previous slide, it will be having a pattern like this. We can create an object where we could pass the properties which we are going to have into object, and the executor function which will help us executing them. Okay, so now if you see in modifiers, let's look at the index.js file so it will be easy to understand. Okay, so we are getting this immutable buffer from somewhere, and then we are just calling this immutable buffer, and we pass the length of this word, hello world, and we are passing the property that is write console.log. I mean, we are just having a write function here, and it will try to write it. Okay, now if you see this write function, let's see how we have implemented this write function and what we do from there. Okay, so what I'm trying to implement is, I'm trying to implement this behavior where it will allow us to read from anywhere. Okay, so we have defined hello world, so it will put the hello world inside a string, and inside a buffer. And then when we are trying to again modify it, like immutable dot write, when we are trying to do, it will basically throw an error that immutable write is not a function. Okay, so we can't modify it after the creation. We assigned one property, but we can't modify it again. So Let's see how we can do it. So now let's say so let's see, look at this class immutable buffer. So it gets a constructor. Inside the constructor we have two type of options, and then we allocate a buffer to that size. So whatever the constant size we are passing, we allocate the buffer of the same size. And then we have some modifiers are basically the operations which we can perform on the object or buffer. Okay. So what we are trying to do is now we let's when we do buffer.allowed, right? So buffer type of object comes up with other properties also and function. So if it is a function, we just continue. Okay. Um, like we iterate through all the properties of buffer, and if it is a function, we continue. Otherwise, let's say we have now we want to separate out swap, write, and fill function. Okay, because these are the functions which will basically modify the buffer. Okay, so we want to change these function and we don't want to do anything at all. So what we will do is we will check if some of the variables are basic some of the properties of this buffer start with the any of the modifier names. Okay, if that is the case, then we won't do anything. Uh, we will just bind the buffer to it. Okay, so it will remain the same, we won't do anything at all. Otherwise what we will do is uh, we will inside of this immutable buffer, right, we will change the property and okay, allow it to do any kind of change. Okay, so if you think about line 15, right, line 15 is basically you can consider it as a, like if we pass read property, right, read property will be assigned to this reference of immutable buffer. But if we are doing any write property, so write property like at line number 13 we will just pass it, and then we will do modifier, like we will like inside an executor, uh, inside this executor function we will just pass the modifier. Okay, so again, now this executor for us was the function, write function, which we had earlier, um, this one. Now if you see, let's look how we can run it. Okay, so it basically gave us all the functionality of immutable behavior. Okay, we just logged immutable itself. So it attached all the functionality of buffer into immutable buffer. But if you see here, it doesn't have any write method. All it does it has is the read. Okay, then there are some write, so we can avoid them also with the pattern matching or something. But the direct writes are not available, the ones which we declared in modifiers, right, those are not available. Now if you try to do immutable write, correct, immutable write won't be a function for us. It will throw an error that immutable write is not available, but inside the existing buffer it is available. So this is how we can use revealing constructor. And if you see a typical example of it which you are using in life, day-to-day application development, that is promise. So promise is again an example of revealing constructor pattern, which basically expose two type of executors, that is resolve or reject. I mean two type of modifiers, and apart from that we can't do anything there, right? So what it does is these are the only two functions which will be used, like resolve and reject. They are the only two functions which can execute there. Apart from that, we can't modify anything there, so it's immutable. Okay, so that's the example of it. Now let's think about the different pattern, that is singleton pattern. Okay, so singleton pattern is basically uh, what we say. Um, it has very trivial applications in Node.js. So like, and you guys are already using it in most of the time, right? Whenever you are maybe creating any uh, DB instance or any global variables, right? You guys have been using this a lot, but now if we talk about this, it comes up with a lot of advantage, but at the same time it comes up with a lot of disadvantage also. So let's see how we can use this. So like, uh, the reasons why we use it is basically uh, we can uh, we can share the resources with the stateful information. We can optimize our resource uses. Like, instead of having different copies, we can just have a single copy of it, and then we can synchronize the access resource, synchronize the resource across different classes, right? So these are the use cases. But what problem it gives us is that um, it can have different like, let's consider this example, how it can be a problematic thing. So let's say we have a database class from where we are getting the database, okay, and we are trying to instantiate it, and then we are just exporting this as a variable. So as we know that in Node.js, when we do this export, right, it creates a read-only copy. So it will, and in Node.js, all the modules which are being loaded, right, when we do import DB instance from DB instance.js, right, so it will import this DB instance, and it will create a read-only copy. But at the same time, it will create a cache of it inside its modules, loaded modules, right? So it will make a copy whenever you are using it. Like, it will maintain the same single copy of it. But if you see in Node.js, we have this kind of a pattern that um, whenever we are doing any kind of modifications, right, if we have a path difference in, or like whenever we are doing any kind of import, so if we have a path difference, so instead of dot slash database dot js, if we have dot slash database dot js, so it will be treated as a different module, correct? So what it will do is, it will be treated as a different module altogether. If we are using it inside a different package, let's say dot slash database dot js or some other third party location we are using, so it will create a different copy. It won't maintain a single copy of it. So in our application itself, if we are using it in different packages, then it won't guarantee to have or guarantee us that of maintaining a single copy. We will end up having different copies of it, and this will create a problem whenever we are doing a resource sharing or anything. So this is a very important thing to notice, and it creates a lot of problem because we think that we are doing singleton pattern, but that is not fully singleton pattern. So inside a package it is singleton, but if we are using it at different packages at different package level, right, then it's not a singleton pattern. We'll end up having multiple copies. So this is the main caveat of this singleton pattern in Node.js. But how we can achieve this synchronization over the whole application? So um, what we can do is we can use a global variable, and then we can do global.db instance is the new database or something like this, right? So this will guarantee to have a single copy of anything. I mean, single copy of the variable. But this also comes with a lot of disadvantage. Like, um, what if some other variable is exported by the same name, from other library, then it will get changed. So having managed like managing a global state won't be much beneficial. So let's like we have to design very carefully whenever we are designing such kind of pattern and such kind of functionality in our app. And look at the, like we need to find out where we can uh, use it single in a singleton purpose, or like when it can be shared, when it cannot be shared. So this is a typical example of singleton pattern. Let's now talk about the dependency injection pattern. So dependency injection is again, like you guys already know that it is kind of a composition. So in inheritance, we have a problem that we will be doing a lot of like we will be inheriting a lot of properties and a lot of new objects we will be creating. Right? This creates a tightly coupled program for us. Right? If we uh, like it creates a tightly coupled program, and whenever we are doing any kind of change, then again we need to look at how we can whether we need to do any kind of change in child library or child object. So resolve these kind of problems, we come up with dependency injections. What it says is, instead of providing input directly, we inject them as inside we inject them as an external variable inside, like in as an input in the constructor itself. Okay, so um, let's look at the concrete example of it. So consider a simple class where we have let's say we have db.js, which is to create a db, and it will get the db file from it. Okay, and this is basically when we are trying to do anything. So it's like it's a typical example of a blog. You guys can go through the code. So this will create a blog for us, and what we do is, now let's say we want to do, and what we are doing is, instead of look at the blog class, here we have a constructor where we are passing the database. Now database can be anything. Okay, it can be either SQL, or it can be a simple file, it can be NoSQL DB also. But all we are trying to do is, we don't want to be dependent on this, what kind of DB we are doing, we are implementing. So the block class doesn't need to know about it. So what we can do is, we can have DB passed as an input, and then we make sure that DB object which we are passing has two type of options, that is run or all. Okay, so these are the two patterns which we are two functions which we are trying to have, and then it will promisify and create. It will do DB run and DB all. So it doesn't know what DB it is executing into. Okay, it will just execute the query, and then we can, inside the db.js, we can have anything we want. Like maybe we can, right now we are doing SQLite 3db, and if we want, we can go with Postgres. If we want, we can go with any other db also. So this basically helps us of helps us to remove the tight coupling of the objects. So we can enhance db.js independently and block.js independently. The only thing is, we need to keep track of the common things which the things which we are trying to expect from db class. So that's about the dependency injection pattern, and it has its own limitations when we talk about. So this limitations are basically, like whenever we are trying to resolve any kind of dependencies, right, it basically makes it more difficult to understand, like what is the relations what is the relation across the components, right, because we are passing them into constructor instead of inheriting them. Although it is a parent class, but we are, instead of making it parent class, we are passing it as a dependency. So that's a problem. Like you have to create a graph, you have to spend significant amount of the like understanding the code, right? And then basically what it is doing is when it, so it is trying to inject them into the constructor, so at the creation time. So it basically forces us to build the dependency graph by ourselves, right? Because we are making sure that it is getting injected as a dependency, and we do it in the right order. So if we have a large, like we have number of modules, and so it becomes very hard. Like let's say we have button with, then we have button with gray border, then we have, like, let's say something like that. So it becomes really hard to manage these kind of things. So these are the limitations we need to know about this, having a dependency injection pattern. So this is about it. Break time is over. Now let's move to the different pattern, that is structural design pattern. So we have three type of patterns, like proxy pattern, decorated pattern, and adapter pattern. So how many of you guys already know about these patterns?
Okay, 22% people know about it or have used it, and 78% not aware about it.
Okay, so let's start. So actually, now this structural design patterns, right? They basically helps us to like as the name suggests, right? These are for maintaining the structure. So it helps us to realize the relationships between objects or entities. Okay. And like in proxy patterns, we like it is a pattern that basically allows us to control the access to another object. Okay. And like I'll tell you how it works and how we can implement it. And then decorator patterns is basically uh, it's kind of same with proxy, like same as proxy, but it provides some other enhancements on top of the proxy pattern. So we can actually change the behavior of the object also. And then adapter pattern is basically allows us to access the functionality of an object using different interface. So let's see how these patterns works in real life, and let's go through some examples of those. Okay, so let's talk about the proxy pattern first. So proxy pattern is based, as I told, right, it controls the access to another object. We call it a subject. Okay. And the proxy and subject basically have a similar like have identical interface. Okay. So what we can do is we can swap one another transparently, so there won't be any difference on how we can access them. So it's kind of a you can consider it as a slave copy of the main object. Okay. And then we can control the access to the original object, and we can do some other operations like changing the other functionalities of it. So let's see how it works. Okay. So let's take a typical example. Okay. Let's say we have a database, and database is basically all the clients are using this database and making a lot of queries. Some of the queries are basically very long, and some of the queries are smaller, right? And what what happens is like um, these queries over the time they become really slow. Like when we have long queries, they are really slow. So this creates a lot of problems when somebody else is trying to access the DB at the same time. Correct. So what we can do here is like we can do some lazy implementation, like lazy initialization. So instead of creating the objects again and again, like making the query again and again for everything, we actually call, like we maintain some cache or do some kind of optimization, and then um, like, do some lazy initialization of it. Okay. So this basically will create a lot of, like, it's very hard to manage, right? And let's say, like, let's in the ideal world, uh, we would want to put this code directly into our objects class. but that's not always possible. For instance, the class, let's say if we are using any third-party library for database, we can't do any kind of implementation or any kind of change on top of it. So how do we control the access to our database? How do we like make sure that our database works reliably and we don't need to do any kind of change? So what we can do is we can create a proxy which will act like a database for us, and that proxy will we will be having full control over proxy, but only proxy can access the database. So it will be having a single point of control, right, to over the database. But client are basically trying to connect to database, but they will be hitting to the proxy itself. Now this proxy can be managed by us. So this proxy is basically like we can implement any kind of changes we want to have, like maybe maintaining a connection pool, or maybe we can do any kind of lazy initialization of it, or caching the data, right? Or maybe having a master slave replication inside or like through the proxy itself. So we can do all kind of modifications we want in the proxy itself. We don't need to we don't need to do any kind of change in the database itself. So this kind of like this is how the proxy pattern works. Okay. Now let's talk about the use cases of it. So this basically helps us to do the logging or data validation. So whenever we are passing any kind of data, right, to the database, so we need to do some kind of logging, like what kind of data we are inserting and whether the inputs are correct or not, because it can create a lot of problems if we submit it into the DB directly. And then it gives us like it verifies security contexts. It does some like we can achieve some kind of cryptography encryption or decryption here. Then it can cache the data for us. And let's say if we are having like if the database connections or any kind of connections that we are making, those are expensive, then it can delay those connections until it is really necessary. Otherwise it can return the data from something else, like maybe caching. Like, so these are the typical use cases of it. Now let's do one thing. Let's make a calculator which will help us to understand how this works. Okay, so let's go with the calculator. Okay, so let's here what we do is we have a stack calculator class, um, and this stack calculator is basically having a stack, and then it has some functions like put value, get value, peak value, clear, which will clear the stack, then divide, multiply, and uh, so this is a typical calculator. Okay, now what we can do is instead of like if you want to implement a proxy over it, right, what we can do it, we can inject it as a dependency. Okay, and then we can modify the operations accordingly. So what we will do is we will have the same operations as were there in stack calculator. So get value, divide, multiply, clear, put value, everything we will be having. Okay, and the functions which we want to control, right, only those we will change. For example, we change the divide functionality, and we came up with some additional logic, right? And then we are again calling the this dot calculator dot divide. So this is basically delegating like it if it is valid, it will delegate to the subject, otherwise it will throw some error. So this is what we are trying to do, like we are trying to put some error control over it. And then rest of the functionalities are similar. So what we do is let's say now to implement it, right, first we created a calculator instance, and then we created a proxy, that is safe calculator, where we have a better error control, and we passed through it. So we got a safe calculator. Now whenever we are trying to do any kind of operation on calculator only, right, so everything will work similarly, But when we do this, all right, when we try to divide from 0, something like this, uh, then it will throw an error from the save calculator. It won't delegate the method, delegate to the subject. Okay, so we will control the access to our subject. Our subject is basically the stack calculator here. Okay, so this is what we achieved via classes. So what we did is we created a new class, and which will which is a composition of the calculator, and then we control the access of it. Okay, and if you note here that, like, if you notice something, that we didn't add any additional logic, right? And the calculator reference, right, it also remained same. We didn't do any kind of changes here. So the calculator divide method is still same. We didn't do any kind of change. But the similar thing we can achieve with object augmentation also. So how does it work is, uh, let's consider the similar calculator, but this time we do it with respect to function. So we are having this stack calculator same, but instead of creating a new create save like we save calculator class, we create a factory of it. I mean, we create a new function, that is create save calculator. Okay, now what we will do is we will have similar functionality. Okay, we will do calculator dot peak value, something like this we will be again having, and then we will be doing this, that constant calculator is this, and then we will be getting a save calculator from create save calculator. Okay, so this will return us a new object, and then we can call the divide functionality and everything. Okay, so this is how we can achieve if we are doing any save operation. Okay, now the same thing we can achieve with so in node.js, so it provides us a lot of flexibility, and it comes with built-in proxy objects. Okay, so we don't need to again create all the classes differently and then perform all the operations, right? What we can do is we can use a built-in proxy object, which will help us to create a proxy for anything. So this is a typical syntax for it. We have a new proxy, and then we have a target and the handler. Target is basically the subject, okay, on which we are applying a proxy, and handler is what the changes which we are trying to do. Okay, the change in the behavior we are trying to do. So there is a limitation that it may not work in old browsers because of the transpiling issues, right? You can read more about it, but let's stick to the design patterns right now. Whenever you have time, you can read about it. So let's see how it can work. Okay, so uh, now if you see here, we have this save calculator. Okay, so this basically um, um, let's consider a similar class. We have the similar stack calculator, right? And then instead of now creating a new object by ourselves, right, we use the proxy. Okay, so this proxy, if you see it line number 60, we are creating a new proxy, and then we have this calculator as a subject and save calculator handler. So save calculator handler will implement some functionalities like get, set, has, something like that. Okay, so these handlers are basically taking care of all the operations which we are trying to do. Okay, so get basically helps us to uh, get the target property and do any kind of modifications here. Okay, then it will return a new function. Okay, and if it doesn't match to anything, then it will just return all the other target properties. So whichever is required, we only change that. We, instead of writing the whole code again and again, we are just doing those kind of changes. So what we do is, if the property which we get is equals to divide, then we will get the target reference, we will get the target peak value, we will divide, and then we will get just call target dot divide if everything works. Otherwise we will throw a new error. So everything is similar. We are just getting the target reference in get function, and then we are comparing the properties. Okay. So if you see every function or every object in JavaScript, like every function has some properties in JavaScript. Every object is having some properties, right? They are treated as an object only. So like every object can have some functions, and then it can have some literals, constants, other things. So this is what we get into the those properties we get uh, into the um, properties. So this is the divide property, this is multiply property, like that. So we can achieve this thing. Now if you notice this, that we haven't changed any property of target here itself, here again, right? So the proxy is basically not changing the existing target, existing subject. Instead what it does is it creates a new copy of function and allows us to do any kind of modification there. So instead of changing the subject directly, it will just change the properties which are needed. Okay. So that's where the proxy pattern comes. Now let's talk about the decorator pattern. So decorator pattern, as I said, that it is just an extension of it. So what we do is, in decorator patterns, like everything is same. You can consider it as a like you can consider an example of Russian doll, right? So everything looks similar. We kind of pretend one thing to behave like a other thing, but we are trying to enhance its functionality. So Russian dolls always they look same, and we wrap some functionality over it, right? So it basically changes the behavior of existing product. So you can visualize this better in this way. And now let's talk about the proxy handle, like how we can achieve it. Okay. So give me a sec. Yeah. So now let's talk about the, so we can achieve the same functionality with composition. If you want to go with composition, we can have, now if we want to add any new method, right? We can add any new method here. So we have an enhanced calculator, and enhanced calculator will basically take the composition of stack calculator and add some new methods here. So this is the way we can achieve a decorator pattern. It will create a new function for us. Okay. And it won't change the existing calculator. So that's one way to achieve it. Then second way is basically object augmentation. So in object augmentation, we do the same thing, but here we do it via method itself. So we add a new property called calculator.add, and then we are doing the operations we want, and then sometimes we modify it, and we do it like this. Okay. So now if you see, we are actually changing the reference of calculator itself. Like we are adding some new properties inside that and modifying the existing ones, right? So this basically is changing the now if you see stack calculator, so calculator and enhanced calculator, they are going to have the similar reference, because we are passing the calculator and then we are returning the calculator here inside patch calculator. So we are just changing the existing properties and adding some new ones. So both are the similar references only. Okay. And then we kind of have a error control or anything we want here. So this is how the decorator pattern works. Okay. And you can achieve that with the built-in proxy object also. uh, So what we do is we are just creating a new proxy, and then we are just having a new one. So if the property is equals to add, we do this. So let's say we want to call add function, right? It will just create a new function for us and return the results. So now if you check here, in built-in proxy, it's not again modifying anything here. It's creating a new function and then it is returning it. Okay, it's not modifying the target itself. So that's the change with that's the advantage of built-in proxy handler. It doesn't modify the existing functionality. Okay. So be okay. Please keep that in mind that whenever you are changing any, whenever you are using any proxy method or anything, right? You need to check whether you are modifying any reference to it, like modifying the reference directly, or you are using the proxy handler or something like that, because this may create problems in your production application, right? So that's about the proxy and decorator patterns. So now let's talk about the limitations of it. So decorator patterns, so we talked basically enhance the existing object and it injects the new behaviors. But proxy patterns basically control the access to it basically controls the access, and it can modify the it can modify with virtual object, right? It cannot change the existing behavior of current object. I mean the subject. And decorator patterns, it acts like a wrapper where you can have different type of object. You can decide what to do, what not to do. You can enhance the capabilities of the existing object. But in proxy, you can't do. You can't change the original interface. So this is about the proxy and decorator pattern. Now, if we talk about now, let's talk about the adapter pattern. So adapter pattern is like let's think it in that way that it allows to access the functionality of object using a different interface. What I mean by that is, in real life, if we take a real life example, what we are saying that it is we will be able to charge uh, Type C USB phone with um, USB 2.0 cable itself. Okay, so it allows us to change the appearance of it. So all we need is to know is that we are having some cable. We don't know whether it is Type C or Type uh, under the hood it is working how, but it will be able to charge our application. I mean our phone. So it's like that. So it basic adapter is basically convert that adapter is basically converting that USB 2.0 cable to USB Type C, and allows us to perform the same functionality again and again. Okay, so this is what adapter pattern means. Now let's see how it works. Okay, and what we can do from this. So let's see a scenario. Okay, so this is a car to rail adapter. So if as a client I'm just again driving a car, okay, I don't know what how it needs to be done, but it needs to drive into rail line as well. So we will create an adapter and it will uh, modify some properties, and it will allow us to uh, do a it will allow us to walk into rail line. Okay, so this is the adapter which we are trying to create. So it will enhance the capability, it will change the appearance of it altogether, and to the client it will again look the similar. The ports and everything will be similar only, but the functionality will change. Okay, so we have this adaptee that was that is the main object for us. Then we have a adapter in middle which will change the behavior of adaptee, like it will appear something different for us, right? And then at the end everything will be looking similar. The client will always do the same functionality, but the results will be different. Okay, client will still drive the car, but it will be driving it will get drive in rail line instead of road, right? So it's like that. So now let's talk about design, like how do we implement it. So we have this. Let's say we have a logger implemented in our application. So we have this old logger, okay, that is taking some info as a text, and like there are two functions, info and error, and those are expecting only text function. I mean text as input, and then they are doing fs.append file and appending some info here, and we are calling this. Okay, now let's say we change this functionality, okay, and we come up with a new logger, and there is only one function we have which will expect a level and text, and now the whole functionality is changed, right? So the client which is trying to access this logger will need to either do a write log, like it need to change the functions, but it's not a right way for us, right? Because we don't want anything to change at the client side. Everything should be similar whenever we are changing at the backbone. So what we will do is we will write a new adapter for it. So how it will look like is it will take the function name, okay, it will treat then it will be having two function that is similar to the old logger. Okay, so if you see here, if we have info and error that is expecting text and text, so to the client it will still remain the same. It will still call the same functionality like this, but under the hood it will be calling the write log with info and error parameter. Okay, so now the whole under the hood functionality got changed, but to the client it remained same the way it used to access. So this is how we can use adapter patterns. Okay, so I hope you are clear about it now. Now let's move ahead with behavioral design patterns. Okay, so behavioral design patterns are basically we this is basically comes handy when we are trying to do any kind of changes how the object we want is should behave on the runtime and in its application life cycle, in the life cycle of it, right? So there are a couple of patterns we can follow to change the behavior of existing object and to control them. So one is a strategy pattern, then we have state pattern, we have a middleware pattern, we have command pattern, we have observer pattern, and we apart from these we have some other patterns like template patterns, we have iterator pattern. Some of them we have already talked about it. So we have already talked about observer pattern, we have already talked about iterator patterns earlier in my previous session. So this session we are going to focus on majorly four: strategy, state, middleware, and command patterns. Okay, so strategy pattern, if I talk about, so strategy pattern is it helps us to change the part of a component, okay, whenever we have any specific need. So let's say we will talk about it later, like when we are trying to when I'll brief you about the strategy pattern. And then state pattern is basically it allows us to change the behavior of the component based on the current based on its state. So in React JS we do state management, right? So basically that kind of thing we are trying to do. Then middleware pattern, you guys already know about how we use middlewares, because in Express.js we use middlewares a lot. It's kind of a middle like function which we inject in middle of processing, and it takes care of everything, right? So it's kind of a modular chain we create, pipeline we create of processing steps. Then we have a command pattern, which basically materialize the information that is required to execute. Okay, and this is command pattern is very complex pattern. So we avoid using this, but sometimes whenever we are doing any kind of complex object creations, right, we may need to achieve it. But we can also we will talk about it later. So let's start with strategy pattern first. So strategy pattern is basically it helps it enables an object, let's say we call it a context, to support multiple variations of its logic. Okay, I mean it's in its logic. So what we do is, let's say if we are trying to implement uh, some uh, let's say we are trying to implement searching technology, right? Search engine. Let's talk about a search engine. Now, search engine can do a pattern kind of search. It can do a linear search, right, on the results. It can do binary search on the results. It can do any kind of search, right? So based on the data, we are actually changing the behavior on like how it needs to search. Okay, let's say we get some data that do binary search, then we will do binary search. So how do we achieve this kind of strategy? Like how do we change the strategy at runtime? So that's where the strategy patterns comes. Okay, so the context basically implements the common logic of the family of algorithms. Okay, and then we have some strategies which basically are some mutable part of the application. So let's say how it works. So we have this client. Okay, the client is going to call the context, and this context maintains a strategy controller. Okay, that will change the strategy whenever it is needed and however it is needed. Okay, so it will switch between the strategies. So if so what it does is like it will dynamically select those strategies, and like you can, like if you think about it more, right, it looks like similar to the adapter pattern, because like we are actually trying to perform this, like to the client everything is same, right, but we are actually changing the whole under the hood the whole functionality, correct. But if you think about it more, right, these are not same. There's a really good difference between these two. So adapter basically is not like adapter basically is not gonna change and like change the behavior of adaptee. Like it's not gonna change the subject to subject which we have, as we saw earlier. So everything it will do is at the adapter level, it won't change the subject. But in this, we are actually changing the context, right? Because we are changing the strategy how it needs to behave. So though, but it will be changed dynamically. So this is the this is the difference. Now let's talk about an example. Okay, so let's say, yeah. So let's see. Uh, let's say we are going to implement a dynamic configuration loader. Okay, so we can have something like the configurations can be in like JSON format. It can it can be in ini format. Okay, so like according to what we pass, it needs to load the configs dynamically, and everything should remain same. Okay, we don't need to change any code, so we will just call the config. It will it will call the configs with the strategies. Okay, and dynamically the behavioral will change. Okay, and then we will just load the configs. Okay, and load will take care of what strategies we need to follow whenever we are doing the load operation. Okay, so if you see line number 6 and 11, right, both of the functions are similar, right, but under the hood they are working differently. So if you look at it, let's look at this config class. We have this data, we have format strategy. Okay, so we get like what kind of strategies we need to follow. Okay, then we have config path. Okay, like get and set configs, and then we have a load function, and a save function. So what it will do is it will take that format strategy, okay, which we are passing, and then it will try to serialize and deserialize according to that. So under the hood, we will be like the strategies which we have defined, right? Those will be having a serialized and deserialized method, and respective to that format strategies which you are passing, right? Those functions will be called. So in index.js, we pass ini strategy and JSON strategy. So if you look at the JSON strategy, it had serialize and deserialize, where it worked differently. But if you look at the INI strategy, right, it works differently here. So everything like is separated into different strategies, the common functionalities it needs to execute, and then we pass it along. We pass it along in the object as a composition, okay, and it can be changed at the runtime. The strategies which we want to load, um, and then a strategy which we want to perform at the save. So then it will change like this. Okay, so this is about the strategy pattern. So now let's quickly move to the state pattern. So state pattern is basically it's spatialization of strategy pattern itself. So where the strategy changes, here we change the strategy based on the state of the system. Okay, earlier we saw that how the strategy can be selected based on the different variables. So let's say we define the config property, right, as an input parameter, and once those selection is done, the strategy remains unchanged for the rest of the life, right? So we can't change the existing strategy again because we were passing into the constructor earlier. But what if we want to change it dynamically according to the state of the object? So if we want to do that, that's where the state pattern comes. So state patterns is something like that, something like this. So let's say if our object is in state A, then it will follow strategy A, and in state B it will follow strategy B, and then state C it will follow strategy C. So let's talk about the reservation platform. Okay, so any kind of reservation platform, it will be having three type of system. Let's say we are doing a room reservation. So if it is an let's say we make a reservation, right? So it can be in two type of state. Either we can confirm it or we can delete the reservation. If it is an unconfirmed state, we cannot cancel it, right? Because we haven't made the reservation yet. So this time, this cancel operation is not gonna work. So it's one strategy that we can have: confirm and delete. But if we are going with confirmed state, let's say our room booking is confirmed, then we can have only cancel. We cannot delete and reconfirm it because it's already confirmed. So it's a different strategy here in confirmed state. And then there is a final state. So in final state we have we cannot do anything. Like let's say uh, at the final date of the reservation, right, at the day of reservation booking, we cannot again cancel the booking prior to some hours. We cannot delete it, we cannot confirm it also. So in final state nothing is allowed. So based on the state of the object, the strategies are changing. Okay, so this is how we can achieve the um, state pattern. Now let's look at the example of it. Okay, so in this example we will be having we will be making a basic fail-safe socket. Okay, this fail-safe socket is basically it's creating a TCP client socket. This does not fail. Like what it does is basically it will try to push the data, okay, to the server itself. But whenever the internet connection is not there, or like whenever some problem comes, right, instead of pushing the data, it will switch the strategy and queue the data in its local. Okay, and then whenever the server comes online, it will again try to push the same data. Okay, so it will change the strategy based on the state of system. Let's say system went down, the state got changed, right? So it will change the behavior. uh, and then again, so here let's see how we can implement this. Okay, so we have let in the client side. Okay, as a client, we are just implementing a fail-safe socket at the port 5000, and we are sending like we are just checking memory uses, and then we are just sending that data into the fail-safe socket at every 1 second. Okay, now we haven't specified any strategy, so it needs to take care of everything dynamically. So let's see how it takes care of it. Okay, so if we go about fail-safe socket, so fail-safe socket internally manages a queue. Okay, and it has two type of state, whether one is offline state, second is online state. Okay, in offline state it will call this dot offline state, and in online state it will call this dot online state. So it is already maintaining a two state. Okay, and then we have a change state function. Okay, so change state will basically switch across the state, and then we have data function, sorry, send function that will send the data. So now if you notice this line number 24, okay, the current state can be any one, like one of these two state, offline or online. So everyone will be having a send function. So uh, at that time, like it doesn't need to know where it needs to send. It is just sending the data. Now it's gonna get queued somewhere, or it's gonna get to the server itself. We don't know, we don't worry about it. So let's see how those states are handling this kind of switching the data, switching the states, managing it, like whenever the system comes offline or online. Okay, so we let's talk about the offline status state. So offline state has a fail-safe socket, like it's getting the composition of it, and then what it does is whenever the system is in offline state, it will push the data into the queue. It won't go to the server. It will just push the data into the queue, and then it has a activate listener. Whenever we call the activate, right, it will set a timeout, which will be like every 1 second it will be again retrying it. Okay, so what it will do is whenever the client is disconnected, right, it will again try to connect, over, like in every 1 second it will try to connect, and then uh, it will attach a listener. Let's say if the connection got established again, right, it will remove the listener otherwise, and it will change the state and it will come online. Okay, so from the parent, state will change, and then let's say if the error, if nothing happens, right, then again it will attach a listener, socket dot once, and it will return the error. Now, if you remember, we are not using socket dot on, we are using socket dot once, because it attached the listener only once. So whenever the state gets modified, right, the socket listener, if anything changes, we won't be leaking the memory. We won't be attaching multiple error listeners. So this is what we are doing in offline state. Now let's talk about online state. In online state, we have this fail-safe circuit, and then we maintain one variable that is has disconnected. We have the same send function similar, but what it will do is it will, after pushing the data into the queue, it will again write the safe. It will again do a safe write. So safe write will basically push the data to the socket, I mean to the server. So it will try to write the data, and it will then dequeue from the queue itself. Okay, so whatever the data was there inside the queue, it will try to safely write it. And then activate function, basically what it does is, in case if the socket runs into an error, that means either it is offline or it is into some error, then it will change the status to offline, and it will start pushing into the queue itself. Okay, so this is how it can change the strategy. Okay, and then server.js is just a simpler file that is just listening to the data and it is logging it. Okay, if so this is how we can implement a fail-safe socket. Okay, so like you can try running this example, it's already in runnable state, and you can get a better idea of it. Now let's quickly move to the new pattern, that different pattern, that is middleware pattern. So middleware pattern, we already talked about it, that like we are already using it with the Express. So it's like a popular term, and that came into picture with the when the Express came into our life, right? The mighty Express. And then like it basically provides us a lot of functionality, like it helps us to parse the body of requests, then compressing or decompressing the data, requests and responses, then managing sessions or encryption or decryption, logging mechanisms, right? It helps us a lot. So I'm not going to talk about how the middleware pattern can be implemented, because we are already implementing everywhere, right? So let's uh, let's understand. So let's see how it works. Okay, so we get an input, then we have a middleware which will do some kind of function, I mean validations or any kind of operation on top of it, and then again it will pass to some middleware or some actual function of the subject. Okay, so it's kind of a pipeline that we create. So that is like we have a middleware manager, and where we maintain all of those actions which we are going to perform whenever the middleware is getting executed, right? So and then we are generating the final output. So it's kind of a chain which we create. Now let's talk about command pattern. Okay, so command pattern is again it has a huge importance in node.js. Okay, because like now if you consider in the most like if we talk about its definition, it's quite like we can consider a command any object that encapsulates all the information that is necessary to perform an action, okay, at a later time. So like it's like we are giving some command to someone, and that can be performed anytime that that person is trying to do any operation, or when a certain condition met meet with the person. Okay, so instead of invoking the function directly, we create an object representing the intention of it. Okay, and then later it's the responsibility of another component to materialize it and then transform it into actual action. So we are just passing it. Okay, we are just passing the commands. So we have like here we have four type of properties, that is command, client, invoker, and the target. Okay, so client basically encapsulate all the like command is basically like encapsulating all the informations that is necessary to invoke the function. Client is basically client is the one which creates the command and provides it to the invoker. Okay, it's invoker's responsibility to execute the command for the target. Okay, and target is the one which is getting executed. It can be like a loan function, or it can be a message like method of an object. Okay, so now using this command patterns, right, we can achieve like it can be um, like command instead of command pattern, or like yeah. So let's look at the example of it. Okay, and then we can talk about what it can do. Um, so let's talk about the status updater service like Twitter service. Okay, so we have this command pattern. So what it does is we have let's say we have an invoker here. Okay, we have a command. Okay, and we have a target, that is status updater service. Okay, and then invoker is running it, then it has some operations on top of it, and then we have like some functions in the invoker itself. Okay, now let's see how it works. Okay, so firstly we will go with status update service. So in status update service we have two type of function, that is post update and uh, state destroy update. So this is the target for us. Okay, we the target has two functions we can execute, and the target is basically can execute any kind of function. It can be a loan function or it can be this method. Okay, and then we have a command, that is create a post status command. So this command is going to have some commands like run, undo or serialize. Okay, so there are three type of commands which we can execute with the target. So if we are executing run command, then it will execute post update function. If we are doing undo command, then it will do destroy update operation. If we are doing a serialize, it will do something else. Okay, these are the commands which we have. Now we have a invoker which will try to which will basically invoke the command whenever uh, to execute. Okay, so it's the invoker's responsibility to execute the command. So what it will do is this invoker will be having some other functions like delay or run it locally or run it remotely. Okay, and then based on that it will execute certain commands. Okay, so we will if we want to run it locally, then it will just run command dot run. Okay, and it will push it into the history. And if we want to have a delay run into the delay, I mean if we want to run it with the delay, right, we can just delay the execution, and then it will return the command, I mean it will run the command with some delay. If we want to do some undo, then we can just like if we want to do an undo, then invoker can like run the undo function, and undo command will be run. And under the hood, that undo command will run the destroy update in which is in the target. Okay, and then run remotely is basically going to serialize the function and send it to the server. Okay, and then we can just do deserialize of it, deserialization of this, and then run the same command on the server. Okay, so this is what it basically does. Okay, and then we have server.js, that is just getting the data and doing anything. Okay, and like this. So now if you see this, right, this is a very complex pattern. Like we first create some target, then we create we create some commands, and then we create invokers on top of it. So this basically um, creates a lot of complexity, and this same thing, right, we can achieve it in in different ways. We don't need to create this kind of complex object, but like in fact if you see like the same we could do the same thing by invoking the state updater service, right, instead of writing so many run command, delay command, run remotely and everything. And even like we could even do use we could even use task patterns like event emitter patterns to do any kind of asynchronous operation if we wanted to do, right. And like if we wanted we could achieve that similar kind of thing um, in a very different way. But whenever we are doing these kind of like this pattern is strictly required whenever we have a complex object. Okay, because that time it will be very easy for us to understand how do we resolve the conflicts whenever it is coming to us. Now if we are, let's say, building a remote RPC system, right? Remote control mechanism. There we pass some commands and there we do everything. Now if we are trying to implement it, instead of with command pattern, if we try to implement it with different patterns, our product will run into some errors, and that will be very hard to debug. So this kind of representation is needed whenever we are trying to do any kind of operations like this. Okay, so this is about the command pattern. I hope you guys know about, got an understanding of it. So I think this is about our session, and in the next session, we are going to talk about different topics. That is how we can scale when we have the knowledge of this. So, what are the patterns that are available when we are targeting scale? What are the architectures we need to follow? And what are the messaging and integration patterns which we can have whenever we are designing any service like that? So, that is about the next session. So, over to you, Sana.
It
Thanks.
was a great session, Nimit. Okay, so guys, we are starting with the Q&A. We can just see one question from Akash that was screen isn't updated. I couldn't get that.
Our screen
So
is not updated.
I think that was in the last, I think second last demo which you were giving. In that it was.
Uh,
Okay. Guys, if you have any questions, you can show it right now. Or I feel the session was very good that you don't have any doubt. Okay, and I also have shared all the links in the chat section. Guys, please provide the feedback. It will help us to come back with many more session, and I would say with better experience and whatever you expect us to do. I think that would be great if you can put it there in the feedback. And apart from that, I have shared the link, like where you can follow us for the future sessions. The next session, which we'll be doing with Nimit, that would be after Diwali, the next week of Diwali, and that would be for a pro level. So I'll try to share the recording of this session also within the next week. Apart from that, the previous session is already there on YouTube channel, so that link also I've shared, YouTube channel's link. So you can probably subscribe the channel or just on the bell icon also, so that you can get the notification once we upload the session. And I shared the Nimit's LinkedIn link also, just in case, like after this session and after the Q&A, you feel like to ask something, you can probably reach him out there. I've shared my LinkedIn link as well. You can reach me out also if you have any suggestion regarding the sessions or regarding anything. If you need any help, you can always reach me out. Plus, I've shared our backend community's WhatsApp link, so you can probably join the link there, and I'll be sharing the presentation deck there. And yeah, feedback link. Please provide that. I think we are having two questions. One is from Akarshan. Just thinking of implementing these design pattern in different requirements in productive manner. Okay, is that a question? I don't think that's a question. So I'll just move it to answered. And it's great to hear that, Akarshan, that you're gonna use it. It's really it's a good feeling that you're gonna implement it in your products. Okay, I'm just moving to answer. Either we don't have any doubt or we didn't understand anything. Okay.
So, Akshan, here, the thing is, here we always have the knowledge like what we need to implement. The only thing is, what we need to figure out is how we need to implement it, which thing will work in which product. So these are not the defined pattern. These are just people came across with their experience. Right? Our project might have different requirement, and there we might have to use combinations of these. So there is not a single pattern that is always accepted.
Or I would suggest, like, just go through the previous section also, Akarshan. So it might be helpful for you to understand this section. And whatever doubts you have. Anyway, like if right now also, if implementing this, while implementing this, if you're having any doubt, you can probably reach Nimit out. He's very much available on LinkedIn, and he will help you out in there. Like even on WhatsApp also, he will be helping you out with that.
So yeah, he has already attended it.
Okay, that's cool then. I'll just move to answer. If anyone else have any doubt, any question, otherwise we'll just wrap it up. Will not take much of your Sunday's time. Fine, great. They don't have any question. We'll just wrap it up. And thank you so much, guys, for joining in here. And thank you so much, Nimit. It
Thank
was
you.
really a great session, and I know the hard work you're putting in here. It's really great. Thank you so much. Bye bye, guys.
Bye everyone.